Namaste and good morning. Good morning to you from beautiful IISER campus in Pune. My name is Vidula Mhaiskar and I work at a place called Garware Balbhavan, which is a recreation center and playground for children. It is located opposite Sarasbag in Pune. First of all, wish you all a very happy Children's Day. Today I am going to show you some tricks, puzzles and riddles. In the at least next half an hour, I hope it brings you some smile on your face and you are also inspired to try at least a few of them. Solving riddles is fun, it is challenging. Sometimes you have to use logic and sometimes you also need a little bit of patience because you have to be at it for a long time. Sometimes you solve it by sheer trial and error, and at times there are a few rules to follow. Of the tricks that I will show you today, some tricks are backed by science and mathematics, some tricks need out of the box thinking to arrive at a solution, some need a keen eye and plain old style observation to solve, and some need pure hand skill to demonstrate, that is hath chalaki. There is a thin line between trick and a science demonstration. I will start by giving you a few examples. Turning an experiment into a trick with just one modification or just by the way you present it. Let me give you an example of a science experiment that can be turned into a trick with just one modification. This is an experiment to demonstrate our lung capacity. For this we need a plastic tube which is actually turned into a bag by tying one knot. I am going to take a deep breath and blow out into this bag by keeping the bag really close to my mouth, and then we will be able to measure the amount of air that was in my lungs because it has been emptied into a bag. I am going to request Ankish to help me with this experiment. Hi Ankish.
Hello ma'am.
So he is going to hold the knot and I am going to empty this bag. I will take a deep breath and blow into this bag. Yeah. So this is my lung capacity, which means, and this looks like a cylinder. So volume of a cylinder is pi r square h. You can find out the diameter of this, so you can find out the radius, and this is going to be around 4 to 5 liters. Now let us turn this experiment into a trick. I am going to empty this bag again. Lung capacity is a good indicator of our stamina. So all the kids want to show is that they have good lung capacity and therefore good stamina and good shakti. So the way they do it is, now here comes the trick that I will take a deep breath, but see how I am going to blow into the bag. Now is this, thank you Ankish, is this my lung capacity? Even if all my body was lungs, this is still much greater than this. Now what is the difference that I did here now? The trick was that I did not hold the bag really close to my mouth, I held it little far. So this is a classic Bernoulli experiment. Daniel Bernoulli was a physicist who was a Swiss physicist who was intrigued by flows and the pressure changes that happened. He showed that when the air is at a higher velocity, the pressure drops down. So whenever I was holding the bag really away from my mouth, the pressure in the area where I was blowing went low, and so the air outside also went into this bag. This is a little trick that was performed. An extension to Bernoulli experiment is this fun trick. What we have to do is just take a small strip of paper, fold it into half first and then close the doors like this. Okay. And now after folding, you open it up and keep it in the form of a C like this on the table. It looks like a bridge. Now the challenge is that you have to topple this paper by blowing. What is our instinct? Our instinct is to blow from the bottom of this paper under the C and see what happens. So instead of actually toppling, this paper actually curves in. What happens is, our instinct is that it will topple and fall like this, but it does not happen. This is a very classic Bernoulli experiment. What happens is, when I was blowing under this paper, the pressure in this area because of the higher velocity of the air went down and actually paper caved in. Now can you find out a way to topple this paper? This is an open question. The next experiment that I want to show you is again injection to a balloon. Here you can say that this is a balloon that is really ill, and it is so ill that no matter how many pills you pop up, he is not going to get well. So, how do we inject a balloon without popping it? Let us see, I have an injection here. Mind you that when you do this experiment, always get a new syringe and needle, never use a used one. So, this is a needle and I am going to inject balloon with this device that I have in my syringe. Let us see. Are you going to close your eyes because you think it will pop? Let us see. All the injection gone in without popping. I think he is not getting well at all. So, I am going to try one more time. So, now again and now it popped. Let us do this again. As you could see, every time I poke into this area which is like really close to the knot, the rubber here is really thick, and so when you poke it with your syringe, it is not going to, and I can inject it with the balloon. The moment I click here, when I poke here, it is going to pop. There is also one way to inject here without popping, and that is if you apply some kind of a tape here and then poke it with the syringe, it will not pop. I am sure you would like to try this at home. Now, we will do a sound trick. We all have seen the straw flute being played, and you know that longer the straw in which you blow in, you make a reed in the straw first and then you blow into it, and longer the length of the straw or the air column, lower is the pitch, and shorter is the straw, higher is the pitch. This is the experiment we have always seen, and now we will try to replicate the same with the bottles and see if we can find some trick or a counterintuitive solution. First of all, these are two glass bottles and I am going to blow into them and see if they make the same pitch. Predictably, they make the same pitch because the length of the air column in both of them is the same. Now, let me pour water into one of the bottles. And now, let me try blowing into them. This pitch is of course going to be the same, and predictably this has to be a higher pitch because the length of the air column is less, which is this is low, this is high. Now, the trick comes when you are asked to tap the bottles. If you tap with any spoon, if you tap this bottle, this is the pitch, and this was when blowing, this was a low pitch, and while blowing this was a higher pitch. And let us see what happens when you tap. This is exactly the opposite, because when you blow, the vibrations are in the air column and air vibrates, and so the longer the air column, lower is the pitch, but while tapping the bottles vibrate and here bottle with the liquid vibrate. So, while blowing, it does not make a difference whether this is water or oil or anything, because the only contribution the water has into generating pitch is lowering or extending the air column. Well, here it is not. So, you can see blowing and tapping give exactly the opposite results. Now, let us look at some riddles that you would love to solve. Any time when I ask you a riddle, you might want to pause the video and think for a minute, because I am going to give you solutions soon after. But if you want to give yourself some time, just pause the video, think of an answer, and then you might want to continue with the video. The first riddle, okay? If one handkerchief takes 15 minutes to dry, how much time will it take for 10 handkerchiefs to dry? You might want to pause, and the answer is of course 15 minutes again, because and provided all the handkerchiefs are put out to dry at the same time, because it should not take more than 15, right? You might think it is 150, but that would not be the case. Now, for the next riddle. A duck was given 9 rupees, a spider was given 36 rupees, a bee was given 27 rupees. How much money should we give a cat? I can count like 5 seconds and you can think. You will have to actually think a correlation between the money and the animal. Now, you will see that a duck has 2 legs, a spider has 8 and bee has 6, and so it means that it is like 4.5 rupees per leg. So, a cat should get 18 rupees. You can make it a little simple by having 10 rupees per leg, so that it is easy. So, a duck will get 9, spider will 36, bee will get 27 and a cat will get 18. Now, a next riddle comes in the form of a poem. एक खेत ऐसा है भैया 14 मीटर 3, चौड़ाई भी सुनो खेत की केवल मीटर 3, बाहर बाहर हर मीटर पर पेड़ लगाए आओ, कितने पेड़ लगेंगे झटपट हमको ये बतलाओ. I will also write it in the chat box so that you will know the riddle, and for that you will have to find the perimeter, which is 3 meters into 4 sides. So, we will have to plant 12 trees. This is a little tricky puzzle. Suppose from a sheet of a rectangular paper, I cut a square of area 25 centimeters square. What will be the change in the perimeter? This is 25 centimeters square. What will be the change in perimeter? Will it remain the same? Will it increase by 10 centimeters? Will it decrease by 10 centimeters, or will it increase by 15 centimeters? Let us see. When the area is 25, the side of the square is going to be 5, 5, 5 and 5. So, we might think that the perimeter should increase by 15, but we should remember that this side will be, say it is shifted here. So, the answer is that it will increase by 10 centimeters. This is Henry Dieudonné's puzzle. Henry Dieudonné was a British mathematician who specialized in logic puzzles and mathematical games. He had actually designed this hinged triangle that could be converted into a square. In fact, he also had this kind of a dining table made. So, whenever he had 2 guests, and he of course was third one, so he had a dining table that looked like a equilateral triangle, and the moment he had 4 guests, he converted this hinged dining table into a square, so that 4 people could sit and eat together. Let us see how. Since this is hinged, I am just going to shift it like this. This will go like this, and the triangle will go like this, and the table used to become from an equilateral triangle to a square, and 4 people used to eat and dine. The next puzzle is that of a cryptogram. Cryptograms are fun mathematical puzzles. Here you can see the puzzle says send plus more is equal to money. Here each letter stands for a digit between 0 to 9. You have to assign the value to each of these alphabets so that this equation holds true. Yes. So, cryptograms are fun mathematical puzzles. Here each letter stands for a digit between 0 to 9. We have to find out what each letter stands for so that this sum stands through. For example, now this says send plus more is equal to money. Here now you can see that there is m here and there is m here. The maximum sum of 2 numbers would be, maximum is 19. So, 9 plus 9, and suppose 1 is carried forward, it would be 19. So, m in any case has to be 1. This is how you have to assign the numbers so that the sum stands true, and I will give you answer for this. Now, here S stands for 9, E stands for 5, N for 6, D for 7, M for 1, O has 0, R is 8 and Y is 2. Now, if you fill all the numbers here, you will see that this sum stands true. I will give you 2 more equations to solve, and you have to find the answers. These are the 2 sums. June plus July is equal to April, and 1 plus 1 is equal to 0. Please assign values to these alphabets and send us your answers. Let us try one fun mathematical puzzle. For this puzzle, you would need 20 seeds of any kind. Today I have a tamarind seed and I have a sagargota. Actually, you should be having all 20 of the same kind, but I have just had 2 separate ones so that you can see how things happen. On an A4 sheet, you draw this pattern and keep the seeds so that all the corners have 2 seeds and 1 seed in between and 4 seeds in the center. Now you can see the addition of all the seeds on all the sides is 6. Now I have to, the fun is that I have to absorb all these 4 seeds in the pattern without changing the addition. Let us see how to do it. You might want to again pause the video and try it yourself, but I will show you anyhow. So, if I add 1 here, and I shift 1 here. Let us see what the addition is. 6, 6, 6, 6. Now, I am going to add 1 here and shift this one here. Again the addition is 6. I am going to add 1 here and shift 1 here. The addition remains 6, and I am going to add 1 here and shift 1 here, and the addition remains 6. Now, see, we have absorbed all the 4 extra seeds inside without changing the addition. The key to remember here is that the 4 squares at the corner are shared by 2 sides. So, any changes you make here will reflect on both sides. Yeah, we tried adding a few extra seeds while keeping the addition same. Now, let us see if I can remove something and still keep the addition same. Now, this time I have my favorite food so that I can eat when I am removing. So, I have some black raisins here. Now, again you need 20 black raisins and or any finger food that you like to eat, and then an A4 sheet of paper. Now, draw this pattern and arrange the raisins in the way I have shown. Now, let us see, I want to eat 1 raisin from here. Now, first of all we will see the addition on each side. It is like it is 12 on each side, right. Now, if I eat a raisin from here and if I have to still keep the addition same, and if I shift 1 from here to here, let us see, the addition is 12 here and 12 here too. Suppose I eat a raisin from here as well. If I shift this 1 raisin here, you can still see that the addition is same. I am going to still eat 1 raisin from here and shift 1 here, and you can still see that the addition is same. I eat 1 more, I am really greedy or hungry today. So, I am going to eat 1 more. If I eat 1 more raisin and shift 1 here, the addition is still the same. If I eat 1 here and keep 1 here, the addition is still the same. So, I have kept the addition same and I got to eat 6 raisins. Again, thing to remember is that this square is common and any changes that you do here will affect all the sides. Now, for one really simple trick. Suppose you have 9 tamarind seeds like this. How will you arrange 9 tamarind seeds in rows so that each side has 4 seeds? You can pause and try, and in the meantime I will show you how to. Suppose I arrange like this, each side will have 4 tamarind seeds. Let us solve some visual riddles and puzzles. This is a classic old horse and rider puzzle. We will keep it in our description box, the link to this, so you can download and actually print and play with this. You can see that there are 2 horses here and 2 riders. You have to arrange these 3 pieces in such a way that both the riders ride the horses. You can actually fold it, but you cannot cut it. Again, you can pause and try. Our whole idea, what we think is that this is one horse and this is another horse and they have to sit on the rider. See, so what you can do is, see, suppose you put this, place this rider on this horse, the second one will not match. No matter what you do, the riders do not match. So, the idea is to tell the kids that these horses are running. The thing to remember is that when a horse runs, the face is never down, the horses run with face up. So, the key to do it here is use the head of one horse from one figure and the rear side from the other figure, and then this is what you can do is that now both the horses and both the riders match. Our whole idea is because we do not remember that we can use one part from here and one part from the other. So, this is really an out of the box thinking and arranging riders on both the horses. Another puzzle is a rectangle puzzle. Again, we will keep the link in the description box. You can print, and these are 4 parts that actually match each other, and you have to arrange them into a rectangle, a very regular rectangle. So, you have to simply arrange these 2 here. It looks really simple, but once you have parts all mixed up, it is a little difficult to arrange, but you will have fun arranging. That is rectangle. This is a classic T puzzle, and so these are 4 parts of a puzzle, and you have to arrange it into a T. Our instinct is to use this notch here and match something up here, but that is not how it works. So, you have to keep it like this. It's been cut in a very interesting way. So, if you arrange it like this, it becomes a capital T. Again the link will be kept in the description box and you can print and play with it. This is a classic Mari biscuit puzzle. Now we have a rectangular paper here, or you can have it in any shape, that has a diamond shaped hole here, and you have to slip in a Mari biscuit through this. Now it seems really impossible to slip because this hole seems really small for the Mari biscuit, but now you should remember, if you align the edges of this diamond in such a way that that you can have an extended diameter, then the Mari can pass through this. Let us see how to do it. I am going to fold it like this and like this, so that two edges align, and I will just separate both the edges so that I can create a nice hole here. And now if you see, the Mari biscuit can pass very easily through this. So the key is to align the edges so that you get a larger diameter. Now the question I am going to leave you with, what should be the lowest measure of this side of the hole so that this trick will work. Let us look at some very simple and fun inversion puzzles. This is for that you just need to have one card sheet square, and let us see how this works. I am going to draw an arrow. First of all I am going to hold it diagonally and draw an arrow, upward arrow like this. I am going to turn it around, and remember to keep this line parallel to the floor, and then draw another arrow. Now remember to keep this axis of rotation the same, and you can see if I flip it, this arrow is up, this arrow is up. Now say I switch the axis of rotation from my left hand to right hand. Now this is up, if I flip it you can see this is down, up and down, up and down. Suppose now I get it in my this hand with down position, again changing the axis of rotation. Now this is down and down. So it can be up and up, down and down, or the moment you change the rotation it is going to be up and down. Now you can have your imagination and do all kinds of things with it. Suppose the problem that we had given our kids as something that is up and down but still makes sense. What kind of drawings would you draw? Now for example, this is a boy who is holding his hands up, and so this is up and up, right. We can call this Tadasan if you want. So this is Tadasan, it is a boy who is doing Tadasan. Suppose I change the axis of rotation to here. Now this goes from Tadasan to Shirshasan. So this is Tadasan and Shirshasan. Suppose I start with Shirshasan again, it will be Shirshasan and Shirshasan again. So this is how it goes the moment I change. What will not change is that if you have a symmetrical figure like this, now this is column drawing, and then if I do this it does not matter, and even if I change the axis of rotation it will still not matter because it is a symmetrical drawing. Another inversion thing can be inversion experiment can be done using refraction. For that we saw here inversion because of axis of rotation. Now let us see if we can invert some things because of refraction. I have a glass of water here and there are two arrows, one pointing in right direction, one in left. Suppose I keep it like this. Do you see that the bottom arrow has changed its direction? Do you see now that the bottom arrow has changed its direction? Now both the arrows are pointing in one direction. This is an inversion because of refraction. Light bends when it travels through air and water, and so you see the image being inverted. Here this beaker and water are acting like a convex lens. This is a fun toy to make. It is a feeding cat. This is a feeding cat toy, and cat actually does it eat? No, but you can see it can actually mimic eating. What does a cat like to eat the most? It likes to eat fish. Suppose I slip fish through its mouth. Let us see if it is like to eat it. Yes, it does. It actually has eaten all the fish. It does not want to actually eat an apple, but apple is good for health. So, I am going to feed this cat apple, and I will request it to eat, and let us see if it eats it. Yes, it has eaten an apple as well. Now, let us be ambitious and see if the cat can do some sums as well. So, 7 into 8, let us see if our cat answers this sum. Yes, it is 56. So, how does this toy work? It is actually a very simple thing to do. Let me show you, and just remove this figure. You can actually do it out of any box. The thing is, there is a slide here, so that whatever I slip through the cat's mouth, the flip side will come out. That is the only thing that is achieved. If you can see it in the camera, this is a very simple slide. So, if I put anything from here, it is going to come out in the opposite direction. I feed anything here, or if I feed apple, apple will be eaten. It is a very simple toy that can be used, that can be made using any used box, and you can just stick up any paper here, and your feeding cat toy of inversion or flipping the sides is ready. Now, I am going to show you some haath chalaki ka tricks. You would love to do them and show it to your family and friends. This is releasing a safety pin from a handkerchief. Let us see how to do it. ये तो पूरा हाथ चालाकी है, so you simply have to learn, and with practice you have to be good at it. So, this is a handkerchief that I have, and I have a safety pin here, and I am going to pin this to the handkerchief like this. इसमें कोई चालाकी नहीं है. See, there is a pin that is lying here. Now, with magic, some magic trick, I am going to release this pin from the handkerchief without the pin opening or handkerchief tearing. Let us see how I do it. Abracadabra, if I say this, and the pin comes out. See, no tearing in the handkerchief, no opening of the pin. Now, let me show you how to do it. It is a very simple thing. There is no science to it. You just have to learn how to do it. So, pehle ye pin, we will push it through like this. The only thing you have to remember is you have to hold this end in your hand and roll it twice. Keep this finger here, and you simply have to pull it, and the pin comes out. Okay. The next trick I will show you is linking paper clips without actually prying them open. I am sure you are going to love to do this and show it to others and also teach it. So, this is a paper strip, and I am going to link 2 paper clips to this paper. The way to do it is this. First, you have to turn this paper strip like this and secure it here, turn it into an S and secure it here. Now, if you hold both the ends and pull it really fast, you link the paper clips. I will show you 2 more tricks to perform. Now, this is disappearing coin. How do you do it? You take a handkerchief like this, place a coin like this. First, let me show you, and then I will show you how to do it. You just have to fold it like this. Now, you just say some mantra and the coin will disappear. So, you just hold from these 2 ends, and if you just gently open this, you will see that there is no coin here. Now, the trick is that the coin very safely sits between the folds of the handkerchief. Now, the key here, let me show you how to do it. The key here is the folding. You keep the coin in the center, and the only thing you have to remember is that this has to be slightly staggered like this, and these 2 can go anyhow. Now, you simply have to pinch these 2 and gently open it, so that there is a fold and the coin sits in between the thing, and then you can show, but earlier for now it is a trick. Now, this is the trick of disappearing pencil. I am going to keep a pencil here and roll this handkerchief like this. You should not be taking a handkerchief that has 2 colors, otherwise you will give away your trick, but for now I need to teach you. So, I am going to use a handkerchief like this. So, you roll it up and just say some mantra, and if you open it up, wow, your pencil is gone. If you want to get it back, you roll the whole thing again and you roll it out, and your pencil is here. Please see to it that you do not use a handkerchief like this that has 2 colors. Now, again, the thing to remember is that when you roll it up and when you reach the top, you simply have to take this top part and push it back. So that now you open, your pencil has actually disappeared in between the folds. And now to bring the pencil back again, you keep rolling until you get this end out and roll it back, so that you get your pencil back. Matchstick puzzles are a fun way to learn how you can shift a few things and transform things from one to another. I will give you two examples. Now this is a diagram of a pig that is being made using matchsticks. Now you have to shift two matchsticks and change the direction of the mouth of the pig from now. For now, right now it is facing to my left, I have to change it to right with just shifting two matchsticks. You might want to try it yourself, but the way to do it is 1 and 2. This is it, and now the pig is shifting seeing in the other direction. This is another a little serious matchstick puzzle. As you can see, these matchsticks make the number 5008. You have to change two matchsticks and make highest number possible. You can try many different things, like you change this to 8, again you have to move just two matchsticks, but the thing to remember is that the numbers increase only when you increase place value. So, the way one of the answers could be, if I just change these two, I make 511081. This is a really high number. Try a few more answers and just email it to us. I will show you one more trick, haath chalakhega. Now this is a rubber band. Let us see how rubber band can jump from these two fingers to these two fingers. First I will show you the trick. Now this is a rubber band that is in my first two fingers. If I simply open it, it will go from here to here. Let us see how to do it. First you have to place a rubber band like this, pull it out and tangle all your 4 fingers in. This is your preparation. Now you go to someone and say that I am going to shift this rubber band from here to here, it is going to jump when you open it. So this is your jumping rubber band. The next thing, now this is not a trick, this is a mathematical puzzle, it is a topological puzzle. It is a cube that can change, that can go inside and out. It is called as an inside outside cube. So right now if I form a cube, you can see that it is colored from all sides. Now by just folding and opening, I can change it to a white cube like this, or I can change it back to being colored. For this you just need a grid like this, made with triangles, right angle triangles and squares. The side has to be the same, and now you simply have to fold it like this and stick it up, and your inside outside cube is ready. This is a puzzle where a parrot is inside a cage. You never want to have any bird inside the cage. So how will you release it? You simply have to move it and your parrot is free. How will you set your parrot free? This is a classic Jacob's ladder, one link of Jacob's ladder. For that, to make this you need 2 card sheets and 4 strips of paper. You can see 2 strips here that have gone from here, out from here, and you stick them here. Similarly, both the strips are like this, and one is parallel and one is cross. For the cross strip again, you put them into cross, let them from back here and stick them here. So that now you have something that can open on this side and open on this side as well. You simply have to slide a parrot here in the cross side, so that you think that the parrot is in the cage, and the moment you slip it like this, the parrot would be set free. This is one link of Jacob's ladder. You can make a long strip like this into linked things, and it will be a nice falling Jacob's ladder. This is a trick of tearing papers. What you do is you take a strip of paper like this, hold it in 2 hands and cut a long strip out of this. You show it to the person standing in front of you or your friend that you just hold it like this. You should not be doing like this. In one stroke you make a strip like this. Now ask your friend to do it. You give a strip like this and oops, it does not happen. Let us try it from the other side. Maybe this strip is wrong. Let us try another one. It does not work. Now, this is really a sly trick. What the way paper is done is that paper is made out of cellulose, and when the paper is rolled out and pressed, the cellular fibers are arranged in a particular direction. Suppose fibers are arranged like this, it is very easy for me to tear, but suppose I try to tear it at right angles, it does not. So, when I was showing you that the paper has to be cut in strips, you can see that I have cut it the way we read the paper. So, this is how cellulose fibers are arranged. So, I can easily cut it into long strips, but now when I gave you the strip, I have cut it at 90 degrees. So, the cellulose fibers have been arranged like this here. So, no matter how carefully I cut, you can never tear a long strip out of it. So, this was one. Another tearing trick that you can try is this. Suppose I have cut suppose I have cut two small sections out of this. The trick is that you have to hold from this side and divide it into 3 parts. It seems very easy, but the moment you try tearing it, it will always tear into 2 and 1 part. This trick gives an illusion of extra paper. Let us see how to do it. You take any paper, fold it into half like this, and then make one cut from the center to the middle line, and from the other side you make 2 cuts parallel, but on either side of the first cut. Now, if you simply twist it, see what happens. It gives an illusion of extra paper. Another version of it is you again fold, first cut it the same, but in the second cut you cut in the form of a V. So, you give this cut and you cut it from here. Again you give it a nice twist, and this too gives an illusion of extra paper. This is a trick that needs a bit of a practice, but it is fun to show and to teach. You take any colored paper and squish it into a ball like this, you kind of squish it, and then this is now this shape is very important. It is very important to have a slight bulge on the top. You can take a glass, or for me this is a ghee pot. Now, you have to, the trick is to place the ball inside the vessel without touching it. So, I can always do it like this, but that is not the way to do it. So, now one way to do is you kind of shift it here, and then before it falls you get the vessel down, so that the ball gently falls into the vessel. But another elegant way to do it is that you roll it up and your ball goes in. This is a classic centrifugal force thing. So, when you turn it around, the ball by centrifugal force is actually squishes against the walls of the container, and then when you lift it up, you scoop the ball along with it. These are 2 or 3 tricks using transparent sheets. Now, this is a card that to make. Let me show you first on a white background. Now, this is a card that can magically have colors, and then the colors can disappear. Of course, there is no magic to it. First, you take a card sheet, fold it into half like this, and on one inside of this card you draw a picture and color it up well. The only thing to remember is that you should not outline this thing. Now, from the top part you cut out a small rectangle and stick in a transparency from inside. Then when you close it up, now with the help of a CD marker you draw an outline. So, now your bird is colored. Now, before you show the trick to anyone, just slip a card sheet in between both the sheets, so that when you pull the card sheet, both the layers are visible and your card becomes magically turns colorful like this. This is made on a black background. This is the color. You close it up and just slip a paper inside. See, this is black and white, and this is colored. Another thing to try with a transparent sheet is this very simple drawing. You take any plastic bag that you have that is open on one side and draw whatever you want to draw. Here I have drawn an underwater scene. Then you slip a black card sheet inside the bag, so that now whatever you have drawn is not visible. Now this is a torch, drawing of a torch, and this is the light that is coming out of the torch. You can simply slip in the torch inside and illuminate your view. Let us see what I can see is that there is a crab here, there is a blowfish and an octopus, another fish, and there is a jellyfish on top. You see a seahorse and a turtle and a starfish. It is a very simple kind of card to make for your younger sibling, and it is fun to make as well. This is a marble run. To show this, you either need a scale with a groove in between, but I could not find one. So, there are two scales here that have been kept really close to each other, leaving just a gap so that the marble can run through it and it has some direction. This is a classic Newton's cradle example, and the thing that you ask your friend for this trick is that suppose I hit with one marble, what will happen? Only one will go forward. Then you ask them, what will happen if I hit with two marbles? Will two go forward or one will go forward at a higher speed? Let us try. So, if I hit with two go forward. Now, the trick comes when I am going to hit with two marbles. What will happen? Will 3 go forward or 2 with a higher speed or 1 with a really high speed? You ask what will happen if I hit with 3 marbles, and you will see that the moment I hit with 3 marbles, 1 is shared and the third one also goes there. Please try this trick. Optical illusions are the greatest tricks on earth. So, let us see a few optical illusions that you can try. This is a persistence of vision thing. What is persistence of vision? Whenever you see something, the image stays on the retina even after the object is removed. Say for a fraction of second, actually to be precise, it is 1/16th of a second. So, before the image disappears, if a second image falls onto the retina, the brain does not perceive these two images as separate and you see it as a motion picture. So, let us try one very simple illusion that you can draw. Now, see, first let me show you how this works. This is called as Nen Matakko. So, you simply have to roll it up, roll the paper up. Let me first demonstrate to you how this works. So, now if I do it really fast, you see it changing. How will you draw this? You take a doubled up paper like this and draw a face. You really have to press it hard so that you see the impression on the next page as well. So, for you it is easy to superimpose. So, now draw an opposite thing, and now your Nen Matakko is ready. You simply have to roll up the paper so that the moment you take your pen back, the paper will roll up. So, roll up and release, and then your illusion is ready. Let us see another illusion. This is a typical cat illusion. Now, this shape is very crucial. First, let me show you which do you think is the larger image. Is the grey cat larger or the black cat larger? You would think that the grey cat is larger. If I switch, you think that the black cat is larger, but actually they are the same. This curve is extremely important. This is, if you extend this down, this is 80 degrees and the lower radius is 3 inches and the larger one is 5 inches. If you can get this shape, then you can always make it into an optical illusion. Our brain always kind of gauges the size by comparison. When you keep this, close to a smaller curve, this will always appear bigger. Let us see some other examples of comparison. So, in these two cases, which center circle do you think is bigger? In this case, you would think this is bigger, and in this case, you would think this is bigger. Again, what brain does is, whatever is near its vicinity, the size is compared to that, and you think that this is bigger because these are smaller. By comparison, you think this is bigger, but both the central dots, circles are exactly the same size. Similarly, this is so huge that this appears tiny, and this is not so big, so this appears big. But again, these two central circles are exactly the same size. Similarly, you can compare the lines as well. a horizontal and in between a horizontal and a vertical line always appears to be longer. So, these two are exactly the same length, but this always appears longer. Again if you compare the size of these two lines, this appears to be longer than this, but they are exactly the same size because here this shape is narrow. Compare the size of this and this line, you think that this is longer and this is shorter, but if you see this, both these lines are exactly the same size. The comparison is between this and this line. You would think this is longer, but these two are exactly the same. Let us compare colors now. Compare the shades, orange shades of these small squares. Do you think this and this color is the same? This and this color is the same? You would think no, you think that this is darker than this, but no, these two orange shades are exactly the same. The way brain interprets colors is by context. Brain uses surrounding colors to judge brightness and shade of a color. So, right now this is light, so this appears to be dark, and since this is dark, this appears to be light, but they are the same. The same logic appears here too. This you have to compare the grey shades of this and this. You would think this is bright and this is dark, but they are exactly the same. Again same thing with the green and same with the grey dot as well. You can try your own combinations and come up with these wonderful optical illusions. Not all puzzles are science, math, logic or even haath chalaki. Language puzzles are fine as well. Let me give you a few examples of language puzzles. Okay, here you go. What starts with an E and ends with an E and usually contains a letter? You want to think? Well, the answer is envelope. Then you can also think of find letters with two O's in their spellings like look, cook, book. Let us see how many can you find. Please write the answers and send us so that we know how many words could you find. Also think of first and last names that have numbers in them. For example, Eknath, Ekbote, Trilok, Hazare, Pancham, Saptarshi. You find out again the last or first names with numbers and give us your answers. This is a fun way to be familiar with words as well. This is called as a cat grid. You can come up with grid of any numbers. Now this is 7 by 5 squares and you see cat has been written like a step down. Now you have to complete these words using just these squares, Now I can give you a few minutes or this is the answer. I am not going to say it, let it be on your screen, but you can write the answers. You can come up with this grid of any kind. String games are amazing tricks. Please learn as many string games as you can. Your fingers will get trained and they always fascinate people. This is a string that I have. Suppose I put my hand inside the string, can I get it out? Yes, I can get it out without tangling. How you do it? You push it in as if you would wash a vessel, turn it around and get it out from here and the strings come out. Let us try one more trick. Now this is a mosquito trick. You can make a mosquito out of a string. Now this is a mosquito that is whirling around, zzz, but we do not want you to be bitten by a mosquito. So I am going to squash it and it is gone. Okay. Also there is a story of a forgetful farmer which I have already told you last time, but the trick is how the knots that you put in your fingers, how can they be released. So this is story of a forgetful farmer who ties knots as and when he does a particular chore, and these knots can be released in one go. So please learn as many string games as you can and have a lot of fun. Finally, I am going to show you 3 toys that are not tricks, but they are amazing to make, and I am going to show you especially because children at our center told us that please show them even if they are not tricks. So 3 of them are simple paper folding activities and one of them is a top launcher. Let me start with a top launcher. This is a top that can be spun like this, right, but let us make a launcher to get this top to spin. For that you take 2 caps and a toothpick and you push it through this, so that it makes for a top. For a launcher, all you need to take is the top part of the bottle and make 2 notches, so that your top can easily sit into this. Okay. Now the way to run it is, you take a thread that has one small toothpick tied at the end, and now you wind the thread over the stick of the top. Let this end come out, let the top gently sit over this. Hold the top gently. Let us see how to launch this top into a spin. I am going to use a tray now, so that it does not fall off the table, but you can do it on the floor. So, just pull the string to get this top to spin. This is your top launcher. These are 3 of our center's very favorite toys that the kids make, and so I really wanted to show you. This is origami, and this is an eating fish like this. You just take a square piece of paper, you do not need any scissor, no glue, and you can make this eating fish like this. You can also make a tinier fish, which the big fish will gobble up. So, this is your fish. Yeah. This is a very simple clapper. To link, the way to make this is, we will send you a simple PDF. It is a very simple trick. One of the kids made this into a eating fish, and a fish actually does not eat a carrot, but our fish does. You can even hear the chomping sound. This is another toy. It is actually a jumper, again an origami jumper. It jumps and stands tall. This is a 3D room optical illusion. It is a drawing that creates a sense of depth. For this is how you draw it. These are actually find out one vanishing point and draw lines that are radiating from that vanishing point, so that you get a figure like this. So, this is the vanishing point, and there are 2 points, one here and one here, to get these small slivers of triangles. Once you have this kind of a figure, you can draw whatever you want to draw in your room. For example, in my room there are 2 doors, there are 2 windows, a frame, a galicha, and a ceiling fan. Once you draw this, you cut on these lines and fold it to form a pyramid like shape, and then color it up. And if I hold it like this, you see, although it actually protrudes out and it is a pyramid, you can see that it is like an illusion, and you see that the room is actually deep. It is a very wonderful optical illusion. So, if I turn it around also, and if there is differential lighting from both sides, it is even better. This is a picture in a plastic bag. It is a refraction trick, and then if I immerse it in water at a particular angle, you can see that the picture, that is the part of the picture that is immersed inside, is black and white, and the moment I pull it out, it is colored, black and white and color. Let me show you how it is done. So, this is a small Ziploc bag, and you take a card sheet and you draw whatever colored picture that you want to draw without drawing an outline. Then you push it in the bag like this, and with the help of a CD marker, you draw the outline. Then you blow slight air into this and close the Ziploc bag, and your trick is ready. What happens is, the light that comes from the colored paper has to refract twice, bend twice, once in the air that is inside the bag and then out of water, and the outline has to refract only once. Because of the double refraction of the color, it goes out of the bounds of your eyes, and you do not see the color, and you only see the black and white picture. Let me see if I can show you again. This is a coin trick. You can see that there are 2 coins and a glass, and you can see both the coins right now. What happens if I fill it with water? Can you just see this coin now? No, it has disappeared. The trick was that this coin is placed inside the glass and this is placed below the glass. Now, again that is a double refraction thing. The light from this coin has to pass through that little air that is in between, then the water, so it bends away from your eyes, whereas this is only refracting once and you can see it. Can you make this coin visible? Of course, yes. Let me see if I can do it. You have to pour a little bit of water so that there is no air here, and now there is just single refraction with the help of because of water. And now, can you see this coin now? To make this coin visible, what we did was, we removed that little bit of air that was there between the coin and the base of the glass. You just actually top it up with a little bit of water and immediately place the glass, so that there is single medium of refraction, and now you can see both the coins, the one that is inside and the one that is kept outside the glass as well. Let me show you one very fine trick that you actually see it in your 6th grade textbook, and you know this much, that if I take a glass and I fill it up with water, right now I am going to fill it up completely, but you know it does not matter how much ever water there is, the ball that is hanging in here will not fall. So, I am just going to invert it, and if I release my hand, the water does not fall, and you also know that it does not matter how much the amount of water, but it does not fall. Now, this can be made into a very tricky thing. So, suppose now I have a, so now what you do is, you fill the thing with water, you invert it like this, and you ask people what will happen, will the ball and the water fall or no. So, you go on asking questions, and at one point you can do something, a small trick, that no matter what answer they give, you can prove them wrong. Let us see how to do it. For that, what you need to do is make a small tiny hole at the base, and now what you do is, you fill it up with water. First you put your finger on the base, keep the ball like this, and you invert it, and ask people. If they say that the ball will fall, you do not release the hand, release the finger from the hole, and if they say no, now the ball will not fall, you just release it and it will fall. So, anyway, because of this small trick, you can prove anything wrong. This is an extension to the ball and the glass trick. Instead of the ball, what will happen if we have a cloth? We have all seen chaiwalas on the roads. The way they sieve their tea is that they don't have huge sieves, right? वो कपड़ा रखेंगे, उस पर चाय करेंगे और निचोड़ेंगे. So, you know that water can pass through the cloth. Now, let us see if the same applies to our experiment. Again, I am going to take this glass, I will fill it up with water, and I am going to cover it up with a cloth. Abhi agar if you use chai ka logic, the water has to fall. If I invert it, let us see what happens. So, I am just going to hold it really tight, and if I invert it, let us see what happens. The water does not fall, right? अभी चाय तो गिर रही है लेकिन ये पानी नहीं गिर रहा. Actually, this is a very lovely trick that is used in villages to keep the water cool. उनके पास ऐसा मटका रहता है which is inverted and that has a thing. So, if you press a little bit, पानी आता है and then it can also stop. तो जब भी उनको ठंडा पानी पीना होता है, they will just press it, the water will come out and it will stop, and you can see it can take such lovely concave shape as the water comes out. But it is a surface tension thing, air pressure. The physics behind it is very complex, but you can always try this trick. Tricks, puzzles and toys are always fun to make. They make wonderful handmade gifts and they are very heartfelt. It is also very satisfying to teach someone how to make these tricks, puzzles and riddles. And it is absolutely best eventually to design your own. But for that we have to have our hands very trained and ready. So, we have to make it a habit to keep our hands busy making toys and tricks, and if we even find a piece of paper lying around, just pick it up and fold. So, when times come to design something serious, we have our hands up, running, primed and trained. So, wish you all very happy toy making and tricks performing sessions. Thank you again for listening to me very patiently, and wish you a very happy Children's Day again. Thank you.